Back with another one. I just realized these videos are going like 15 minutes per problem, so we're going to try to speed it up just a little bit. That way people actually want to watch them. We're given a jogger runs down a straight stretch of road with an average velocity of 4.0 meters per second for 2 minutes. What is his final position? Taking his initial position to be 0. Well, first things first, we know initial position should be x0, the initial position of x, and that is equal to 0. Easy peasy. Final position, which is going to be just x, right? Some people have written xf before. We're just going to write x for his final position. And that is going to be equal to, we don't know, we're trying to figure that out. What is his final position? Our average velocity, that's written as v with a little line over it, that is going to be equal to 4.00 meters per second. We're assuming, it doesn't tell you this here, but we're assuming the acceleration of x is equal to 0. He's not speeding up, he's not slowing down, he's just chugging along, having a good run. And then time, right, is going to be equal to 2 minutes. Well, 2.00 minutes. So if we were to draw this, right, we'd have a little runner. He'd be like, hoof, 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 hoof. There's like wind and stuff going. He's running so fast. 4 meters per second. It's not bad. It's good. It's good pace. He's running from a starting position of x0, starting position of 0, and he's going to end up at his final position, which is going to be x, which again, we don't know what that is. We're assuming his acceleration of x over this time is 0. His average velocity is going to be equal to 4.00 meters per second. And over the period of this time, he is going to run 2.00 minutes. Then put a little line here, right? Because we're assuming he stops at this point. Well, not stops. So this is the point we're measuring. If we bring up our equation sheet, we can try to figure out what equation we're going to use, right? Now, we know the average velocity, which is great, but that means we don't know the initial and we don't know the final. We just know the average, right? So that can kind of help narrow down some choices. Well, I guess, I don't know. Maybe he just starts out at 4.0 meters per second squared and he ends at 4.0 meters per second squared. I don't know. It's above my pay grade. Anyway, we're trying to find x, right? His final position. This second equation here should give us what we need, right? X equals our initial position. We know what that is. Our initial velocity of x, which we're just going to assume is 4.0, times the time, we know what time is, plus 1 half ax, the acceleration of x, which we're assuming is 0 here, right? Times time squared. Now, if we write all of this out, we will get, oh, actually, you know what? I don't even need to write this out. That's what copy and paste is for. Now, if we were to write this out, we would get x, because we still don't know what x is equal to x0, our initial position, which is 0, plus our initial velocity, which we are calling 4.00 meters per second, times time, which is 2 minutes, plus 1/2 acceleration of x, which we're calling 0, times time, which is, 2.0 minutes squared. Now, anything times 0 is 0, right? So 1/2 times 0 times 2.0 to the second power, it's all 0, right? So we're left with just this equation, which again, even 0 just disappears. So we can choose to rewrite it. Our final position is going to equal 4.00 meters per second times 2.00 minutes. Now, this is a big red flag here. We're trying to multiply meters per seconds by minutes. It's not going to work, right? So we're going to convert 2.00 minutes to seconds. Obviously, there's 120 seconds in a minute, but if you really wanted to, just for practice, it's minutes, and then you would times that by seconds over minutes, so the minutes would cancel out. 60 seconds. Minutes cancel, you get 2.00 times 60, which equals 120, and our little unit there that we're using is seconds. So we'll just cancel that out and write 120 seconds. God, that looks horrible. All right, we'll work with it. What happens when we multiply meters over seconds by seconds? Right? Seconds would cancel out. So we're left with x equals 4.00 meters times 120. And that would give us about, well, not about, exactly 480 meters. And we have 3 sig figs here and 3 sig figs here. So yeah, that's our answer. How far did our jogger run, right? Because what is his final position? Well, it's going to be, because we set up our, oh, we didn't. Oh no. Okay, well, we're going to pretend we did. The x coordinate, we're going to say pluses to the right, negatives to the left. He ran 480 meters in the right direction, plus 480, right? You don't have to put plus. But for example, if you're running left, we would have to put negative. But anyway, let's see how we did. We have yep, they have the initial position x0, the final position unknown. They even put a y in their coordinate system, amazing, with the average velocity of 4.00. To find x, they identified the values of x0, average velocity, and t from the statement of the problem and substituted them into the equation. If you notice here, this is where it really, I'm not a fan of. I think textbooks should be very explicit. Their equation they're using is jacked up, right? So if we compare, come on, their equation, x equals x subscript 0 plus v over t, that's this. They just left this whole part out. You just had to use your brain and hopefully not make a mistake and realize this part should have been in there. But since the acceleration we're assuming is zero, that just cancels all that out. So they skip that whole step, which can throw new people off. So I'm not a fan. But it, ultimately, they got the same thing: 4.0 meters per second times 120 seconds. The seconds cancel out, and they're left with 480 meters. Easy peasy, right?